Hi, good evening. So today we're looking at the 12th worksheet of this booklet. I think we're on page 13. Okay. So on page 13, okay. Let's move it up a bit. So we are told that, let's keep the diagram in focus. We are told that the rhombus P, Q, R, S. We are told that PQ is 26 centimeters. So there's a rhombus, so all the sides are equal. That's 90 degrees. Diagonals bisect the vertical angle. There's basically 6 properties dealing with the rhombus. Okay, then we are told that QS is equal to 48. So that is 48 there. Okay, which means to say QT is going to be 24. So diagonals bisect each other. Okay. So that's 48. Calculate the length of PR. PR. Okay, so at this point we would need the theorem of Pythagoras, which you guys wasn't exposed to at this point yet. But let's do what is needed, which is the theorem of Pythagoras. Okay, so firstly we need to say that T2 has to be 90 degrees. T2 is 90 degrees. Why? Because diagonals are perpendicular in a rhombus. So let's write it down. T2 is equal to 90. Sorry about the noise in the background. T2 is equal to 90. Diagonals perpendicular in a rhombus. Okay. So we got that to be 26 centimeters. Okay. So in other words, we have a triangle looking like this now. That is T2. T2, that is 26 here. That is 48. So QT, 48 is going to be, as you can see, we know that is 24, but it's not on the diagram, so we must state it, okay? So we have to say that QT is equal to 24 centimeters at this point. Why? Because the diagonals bisect each other in a rhombus. Diagonals bisect each other in a rhombus. So we have that. Okay, in this case, we will be able to calculate PT. Okay, I'm going to calculate PT by using Pythagoras. So PT squared is equal to 26 squared minus 24 squared. Okay, and the reason there is Pythagoras, and it's with angle T2 equals 90 degrees. We have to mention the angle that is 90 when we apply Pythagoras. Okay, so 26 squared plus minus 24 squared gives you 100. So PT squared is 100. So the square root thereof is going to give you 10 centimeters. So coming back to the question they're asking you, that is 10. They want to know RQ. The whole length I wanted to know, which is that length there. So if that is 10, then TR is also 10. Okay, so we're going to say TR is 10. TR is going to be 10 centimeters. Why? Because the diagonals bisect in a rhombus, which means to say they are equal in length, so the diagonals cut each other equally. So therefore, PR is equal to 20 centimeters. Or I could have left this out and gone straight into saying that PR is 20 centimeters there. Okay. Alright, let's look at the next one. L. We are told that A, B, C, D is a kite. So if there's a kite, that length is equal, there's 90 degrees, and that angle is equal to that. There are five properties of a kite. Okay, you should know them all. We are told that a kite diagonals intersect at E. Okay, with BD from there to there, BD is going to be 30 centimeters. Okay, which means to say PE is 15 and ED is 15. Why? Because one diagonal bisect the other in a kite. AD's length is 17. Alright, then DC is 25 centimeters. Determine AE. AE is this length here. Okay, so again we would have to apply the theorem of Pythagoras here. Okay, so this length here first is going to be 15 centimeters. Why? Because the one diagonal bisect the other in a kite. Okay, so BD or ED is going to be 15 centimeters. Okay, so we said one diagonal bisect the other in a kite. Okay, one diagonal bisect the other in a kite. Remember, whatever is not on the diagram, we must state it. Okay, so one diagonal bisect the other in a kite. For the theorem of Pythagoras, I need to know, I need to use a 90-degree angle. So angle E2 is equal to 90 degrees. Why? So diagonals are perpendicular in kite. There are three shapes, or three quadrilaterals, not shapes, three quadrilaterals where this rule is evident. In a square, in a rhombus, and in a kite, where the diagonals are perpendicular. Okay, so there we got 90. So now we can say that AE squared, now the theorem of Pythagoras, AE squared is equal to 17 squared minus 15 squared. 15 squared. And the reason there is Pythagoras with angle E2 equals 90 degrees. Okay, so that can be calculated. So it's going to be 17 squared minus 15 squared gives you 64. The root thereof is going to give you 8 centimeters. Okay, so they have answered the first question. So I'm going to put there 8. Then they want to know AC. Now AC is this whole length here. Okay, so to work out, there's no, let me just check here. Could I use, but no, there's no way of using Pythagoras to work out the whole length there because this is not given 90. Okay, however, what we can do is we can apply Pythagoras in this triangle. You just change the color. I'm going to write it here on the side because of the time, the space here. I'm going to write here for this one number 2 in triangle EDC. Okay, in this triangle here. E3 is 90 degrees. Where do you get that? Diagonals perpendicular in kite. So the diagonals are perpendicular in the kite, so that is 90. Now I can apply Pythagoras. So I'm going to say that EC squared is equal to 25 squared minus 15 squared. And the reason there is Pythagoras with angle E3 equals 90. Remember, when you use Pythagoras, you must say which angle is 90 degrees. Okay, so EC squared is equal to 25 squared minus 15 squared. It's going to give you 400. So EC is going to be 20. The square root of 400 is 20. So that's 20 there. But remember, what was the question? The question was for the length of AC. Therefore, AC is going to be 8 plus 20, which, because that is 8 and that is 20, so give me an answer of 28 centimeters. Okay. Then, let's get the last one quickly. Then they ask you in number 3, B1 if A1 is 20. Okay. B1 if A1 is 20. So if A1 is 20, this is also 90 degrees here. Okay, I'll carry on in the next video.